In this video, we're going to look at the graphs of tangent, secant, cosecant, and cotangent. So if we remember, tangent is sine over cosine. And so when we think about the domains of functions or what things kind of cause issues with functions, if you have a rational function, so you have one polynomial divided by another, then you have issues when your denominator is 0. Similarly, with tangent, when you have sine over cosine, anything that would cause that cosine to be 0, then that's going to be problematic, right? It's going to cause issues in the tangent function. So whenever cosine is 0, we saw in our last video, cosine is 0 at the odd multiples of pi over 2. So at pi over 2, we're going to end up having a vertical asymptote at 3 pi over 2, at negative pi over 2. And so this picture ends up looking like this. So the picture of tangent, it has a bunch of vertical asymptotes. And those vertical asymptotes occur exactly where our cosine is 0. Now the x-intercepts, those are going to occur at all the multiples of pi. The y-intercept, it occurs at 0 itself, right? Right there. The domain of this function, it is everything except for those odd multiples of pi over 2. So writing this can be a little bit tricky. I will write it in this way. So it is all real numbers, minus the set of the odd multiples, 2n plus 1, of pi over 2, such that n is an integer. That vertical line in this set notation, it means such that. So that's our domain. The range here, the y values that we could get out of this, we could actually get any y value at all, right? So every real number. This is an odd function, and if we were to plug in pi over 3, this is tangent of pi over 3. Tangent of pi over 3 is sine of pi over 3 is 1/2. Cosine of pi over 3 is root 3 over 2. And so we have 1 over square root of 3, which is root 3 over 3. So that's our tangent graph. A really quick rundown of that. For cosecant, if we remember, it is 1 over sine. And so I often, when I go through this, I will imagine a sine graph. Sometimes I will draw my sine graph explicitly. So this isn't part of the cosecant graph, but I use it to draw the cosecant graph. So wherever sine is 0, my cosecant graph is going to have a vertical asymptote, because cosecant is 1 over sine. And then the cosecant graph, it's going to be this magenta color. It's going to just touch that sine graph at each one of these points, and it's going to have vertical asymptotes whenever sine is 0. So that's our cosecant graph. For a secant graph, it looks similar, only we build it off of a cosine graph. cosine graph looks like this. So we have our cosine graph. We're going to have a vertical asymptote whenever cosine is 0. And just like the cosecant graph, it's going to just touch the cosine graph. When it hits either a peak or a valley. So that's our secant graph. And finally, our cotangent graph. It is going to have vertical asymptotes at the multiples of pi. It's very similar to the sine graph or to the tangent graph, except for it goes opposite. So instead of increasing from left to right, it is going to decrease from left to right. That's our cotangent graph. Perfect. So now all of those are our trig graphs. We will use those at a variety of times. It's good to have a sense of what they look like. All right, in the next video, we'll talk more about what's coming up in calculus. We will see you then.